Distance versus time. There are two cases in this graph. In the first case, we're given the position in reference to a non-moving origin and the time. For example, a person leaves his house and walks a few blocks. Then he stops at a shop to look at some things in the window, and then he continues walking for a few more seconds. So we're told that position X and time and position X would be something like this. When the time was 0, when they started moving, he was nowhere but at the origin. As time passed by 1 second, he was 1 meter away. This distance is measured in meters. This time is measured in seconds. 2 seconds later, he was 2 meters away. 3 seconds later, he was 3 meters away. And 5 seconds, he was 5 meters. And then he stopped. At that place 5 meters away from his house, and he stood there for about 3 seconds. So we stopped at 5, second 6, second 7, second 8. He was at the same place. He never moved. And then he moved a little. That's when he stopped at the shop and looked at the windows. And then he went on a few more meters. So when it was 9 seconds, he was at position 6, and 10 seconds later he was at position 7. So this is the data chart that we will use to graph his motion. How do we do that? Well, first we have the position axis, and we have the time axis. And when we graph this, we need to know the domain and the range. Domain are all the x values that we're going to use. In this case, our independent variable is time. So it's all the time that we're going to use. We need 0, and the maximum value is 10 seconds. So that's the domain. And then we need the range, and the range in this case is the position value that goes from 0 to 7 meters. That's how the maximum point, the minimum point, the maximum time, the minimum time. We use these numbers and we create our chart. Time should go up to 10. So somewhere here is 5, and we need to divide this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And position is 7. So we go 7, 6, 5, 4, 3, 2, 1, and 0. Position is in meters. And then we plot the numbers. When the time was 0, he was at 0. When the time was 1, he was in 1. When the time was 2, he was in 2. When the time was 3, he was in 3. When the time was 4, he was in 4. When the time was 5, he was in 5. And then he stood there for 3 seconds. 5, 6, 7, it's all the same place. And then he went on to the next position. When time was 9, he went to 6, and when time was 10, he went to 7. So this is the graph of our traveler. This is the graphic representation of the chart. So we have the chart and we have the graph. Next thing we need to know is to calculate the slope. but there are three segments, A, B, and C. To calculate the slope is the same as to calculate the speed. And this is found from the formula that says the speed is position 2 x2 minus x1 over t2 over t1 minus t1. So using this simple formula, we can calculate the speed for the three different segments. Let's do that. The speed for segment A would be, the speed of A will be, you can take any 2 points. So from 0 to 5 seconds, I can use any of them. Let's say I take 4. When we had 4, the position was 4. So I take my position 4 and I subtract another point, which could be the previous point, which is position 3, and in meters, and then I take my time, which was 4 seconds minus 3 seconds, and I get 1 over 1 meters per second. So that's my speed at A. What's my speed at B? I take any 2 points in the B segment, which should be from 5 to 8. So I take 5 and 8. So when my time was 5, my position was 5, and when my time was 8, my position was 5. Notice that I start with x1 from the formula, t1, and then I go x2, t2, and always x on the top, or distance on the top, and time on the bottom. And in this case, I get 0 over 3 meters per second, which is simply 0. And then I find the next velocity or speed, which is segment C, and I take any 2 points. For example, I take 8, my position 8 was, my position 6 was, with time was 9, and my position 10 was when time was, my position 7 was when time was 10. 7 minus 6, 10 minus 9 gives me 1 over 1 meters per second, the same speed I had before. So remember, the slope of the line is the speed. And that's all for today, folks. Thank you.